Welcome back. Hello, everybody. Once again, I apologize for sounding a little too nasally, but I got a cold and work has to be done. So we're just gonna get some work done and, make the best of it. So, last time I lost the shader that I was making, the visual shader for these ferns, and I wanted to make them interactive. Like when the player walks through them, they wiggle. And they also kind of wiggle in the breathe as well. So, we're going to see if we can restore that. But, in order for us to make them wiggle, we have to be able to differentiate between them, and that is done through custom data. And I don't think custom data is available to us from within the visual shader, at least not in Godot 3. So, we're going to see if we can make a custom one. A code shader. So, let's see. Shader material, and then new shader. Cool. I think I can just save this. Burn. Materials. Okay. And this would be... Let's do painted. Okay. And I believe that if I go to the fern material, the code should already be there. There we go. Nice. Okay. Oh boy. Right. Can we get some base shader code in here, please and thank you? Let's see. This would be a spatial shader. Okay, so we need this. That's for the vertex. And then we also need the fragment shader. Hello? There we go. That's the fragment. I need a base fragment. There we go. And then some color is not really what we want. There's a tutorial that we can use to get the base, send data from fragment to light processing. That's cool. Let's take a look at the tutorials. Your first shader. Yes. That's perfect. First 3D shader. And that's vertex. Where's my texture? Is this thumbnail image a different game? That's right, because I am working on a different game on a weekend. There we go. That's what I want. Oh, that's normal map. We don't use normals in this one. We use... Ow. Looks like don't starve. Yeah, I get that a lot. Okay. I need some like baseline code. Your second 3D shader. Okay, albedo vector. Nice. We can adjust these properties. That's cool. Nice. Fragment. Albedo. Fresnel. Texture, noise. Okay. They went with like a water effect. Okay. Here's what we can do. We can keep it here. Go to the ferns. Make a new spatial. Keep the spatial by default and then convert shader to code. And then we can just take this and you know what? I guess we could just save it right there. So we're going to take the material, save it, fern t-res. Beautiful. All right. Fantastic. So what do we want? We need to supply. We got shader parameters, specular, texture. There we go. Okay, that's good. And then we go here. We need to set up the alpha scissor. Oh God, okay. That's gonna be a bit whoops. Call disabled. Nice, suggestions are there. Okay, so now we can see both sides. And then can we do draw alpha prepass? Nope, that's not what I need. Let's take a look. Do opaque depth prepass for transparent geometry. Lighting. Oh, there we go. If written to values below a certain amount, alpha are discarded. That's what we want. So we do, I suppose we have to do it here. 0.5. And I believe the texture albedo doesn't use alpha. Alpha? This is complete guesstimation at this point. Oh wow, I cannot believe that worked. Cool. Okay, 0.2. That gives us a little bit more of the view. Beautiful. Okay, now let me just run this real quick. Verify that it's actually showing. Because I've seen a weird conundrum where it shows in the editor, but it doesn't show in the game. Just like that. And then I imagine that if I close this and then go back to start level, I think it's not going to be there. Quite possibly because the mesh has to be made unique. I have a feeling that that's exactly what it is. Make unique. And then we have to load the fern. Okay, hello. Shader. Oh, well, that's the old one. Wait, did it not save? Oh, you son of a... Burn T-res. Okay, well that's annoying. It didn't save the thing. Okay, convert to code. And let me save this right now. Burn T-res. Overwrite. Yes, I'm gonna save the shader as well. The code. Resource can be saved because it does not belong to the edited scene. Make it unique first. Okay, maybe that will be fine. Let's see. Quick load. Fern. Okay. So once again, albedo alpha. We're going to use the alpha here. Alpha scissor, set to 0.2. Nice. And then call disabled. Yes. Okay. Now, close. Open. Finally. Okay. That's kind of annoying. The fact that we have to make it unique, which means we have to make it a part of the scene. Unless it is because the fern had an MTL file exported with it. Doesn't look like it. Oh, no. So even then, it still doesn't like it. All right. So, let's get back to that shader. See what we can do. So, the first thing we need to do is we need to make it wiggle left and right. This has to be done in the vertex data. Okay, this should make everything collapse. Yes, nice. Now, we're going to take the vertex, make it equals to itself, plus 0.1. Okay, so that just shifts everything to one side. Nice. Actually, that's actually kind of interesting. Hold on a sec. It seems like everything shifts in not the same direction. Oh, that's interesting. I guess it's because the local transforms are different. So their x coordinates are based in their relative space. Okay, that's fine. So we're gonna do sine time. Okay, so that starts making them move around. 0.1. Okay, so that's x. We're not going to touch the y. There we go. And, hey, we're going to try to use the texture. We had a fern mask that we can use as a strength mask. Okay, so we're going to do uniform sampler 2D. This is going to be fern mask gradient. This is not hint albedo. This is just this. Okay, so we go here. Okay, so the texture's populated. We should be able to now use this texture. We need to use the specific points of the texture according to its texture space. So we have to kind of do this. Take the mask mask texture. We're going to take the fern gradient and we're going to use the base UVs. I think that's it. Base UV? Oh, base UV is not here. Yeah, we have to use UV. Why did they do this? Why don't you just use UV? Okay, perfect. So this now gives us a texture that isn't just a bunch of pixels. They're actually mapped throughout the geometry. And then what we can do is we can multiply the, let's say, the red channel. It doesn't really matter because it's a black and white image. There we go. So as you can see, this is now moving only the tips. It doesn't move the base as much. I think there's some pixels on the gradient that are not correctly mapped to the tip. We can fix that afterwards. Now, what if we... You see, right now everything moves at the same time. What if we add vertex on the x-axis as an offset? Okay. And then here we can add vertex on the z-axis. Maybe we can flip them. Hey. Maybe we could use cosine here. Okay. Now, do we have such a thing as world vertex? We need a world vertex. Because I think these are just using their local vertex locations. Default in view space. These are the local coordinates. Okay. World matrix, model space of the world space transform. So there's a way to get position of the vertex in model world space. Object's world space position. This is equivalent to the global transform origin in GDScript. So world matrix XYZ. I don't suppose it's just as simple as this one. Okay, let's try looking it up. Let's see. Godot shader vertex world space. I want to get the position of the vertex in world space, not local space. Okay. My God, my Canadian internet is stupid. Hey, there we go. Okay. Pixels 3D coordinate. I don't want a pixels 3D coordinate. Camera matrix, getting world coordinate in shader. View matrix. World vertex, camera matrix, which is called view matrix, and then we do this apparently. Alrighty. Okay, vector 3 and Vector 4. Doesn't like it. Interesting. Okay, so let's see. Okay. All right. Maybe we can do X and Z again. Okay. I'm surprised at how slow it is. Okay. If we don't do anything for the last value, everything kind of wiggles at the same rate. Let's reduce the world axis. Oh, but you see it still moves it in like local space. And it still moves it at the same time. Hmm. Vertex world. Vertex local. Why did they say that it's a vector 3 though? That doesn't make sense. Camera matrix. You know what? Maybe we need to visualize this. Visualize to see if it works. So I'm gonna take here. We're gonna calculate the vertex world here. We're gonna pass along into the sine function, and then this is gonna be as a part of vector 3, and this is gonna be 0. I suppose it's just going to be inside of this 3 times for x, y, z, or red, green, blue. Okay, and then we will simply multiply by this number. Okay, so now we can actually see what's happening. And I can actually, oh yeah, and it's in the camera space. Dang it. We don't want camera space. World matrix. There we go. Okay. Not bad. So at least this way we can visualize the shader working basically just made it go black. And I think that maybe multiplying it by 2. Whoops. Vertex world x times 2. Actually, that's going to make it more frequent. Divided by 2. Okay. Divided by 8. Or divided by 6, maybe? We're seeing waves here, and I just want to make the waves slightly larger. Okay. So let's do this. I'm going to take this sine, and I think we can settle on having the wind going one particular direction. So let's say that the offset here is going to be, let's do wind strength sine. Now sine produces +1 -1. So if we do plus 1.0 and then divided by 2, then is it scalar or is it float? It's float. Nice. Okay, now before we can use this, I think we may want to use a texture in order to distort the various vertices. Okay, and we can use the visual fragment shader to visualize how the texture looks. Now, I think we have some noise in utility. Yep, noise texture. There we go. We need to set up a variable here. Or actually, hold on. Why don't we just use the noise that we can generate here? Noise texture. And then we do simplex noise. And I think for now, we need seamless, of course. And I think that's it. Perfect. Now, I really like visualizing the the texture. It really helps to see what the heck's happening. So let's go over here, and this is going to be noise. And then we're going to take this noise, apply it here, and then I guess I can do albedo equals albedo multiplied by the noise texture. Doesn't like it because it's got to be RGB. Okay. So I think it works, but I think it's also kind of hard. Actually, hold on a second. For this one, we should not be using UVs. Whoops, I'm going to the script of the wrong thing. This should not be using the UVs. This should be using the vertex world. UVs only have 2 axes of movement, so we're going to try vector 2, vertex world X, vertex world Z. Okay. Maybe we can just do this. Oh, actually it works. Nice. You can see how it doesn't display the texture doesn't deform with the object. So cool. So that's a visualization. That's perfect actually. So we can now we need to upscale this. This needs to be really large. So I think we gotta like divide by 10. It's gotta be a float. Yo, man. Mm-hmm. Maybe we can increase the contrast. Really? I guess yeah. I guess no changes for us then. All right. Fair enough. That's fine. We're gonna do this. We need to increase this even more, like by 50. Okay. So we would only start seeing the noise the further back we go. And then I need to make sure that oh, the shortcuts aren't working while we're in code view. That's lovely. Okay, there we go. So this allows us to visualize the texture. Now what was the whole point of this? The whole point is that we needed to shift it with the winds. Okay. So we got to go back here. So this grayscale value is supposed to use to offset the data. So I think if we do plus time, okay, so it starts scrolling. Good. And I'm going to take this same exact value, maybe times time divided by 2. .2 instead. Multiply by 0.2. Okay, so I'm going to use this. I'm going to take this texture. I'm going to go back here. And then to offset, I'm going to use instead of the vertex position, I'm going to use the red channel. Okay, there we go. So anytime it's dark, it's going to go to the left, and anytime it's bright, it's going to go to the right. Okay. Now this is a vector 3 value, and it has a sign. I think we need to... Oh, this noise texture is not what we want. No, it is. It is what we want, but we're not multiplying it here. This is supposed to be the mask to control the intensity. Okay, and then we can do like 0.3. Okay. I think we don't need this. You know what I want? Let's put this on the y-axis, up and down, for now. Okay, we need to deal with that right there. Okay, where's that fern? Fern, okay. Okay. I don't see anything sticking out of it. Well, that's weird. Oh, you know what? I think I know why. Some of the texture must have the black color in it. Hold on a second. I think there's just a little bit of black color that seeped in onto the tip of this, and it's causing the tip of the leaf to not be offset properly. Okay, that's fine. Just gonna take this, export it to the mask. No, this is child of ether. Bop bop boppity boop 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 boop. Engine, textures. This would be utility. Nope, no, it is fern specific. Fern mask. Nice. Okay, it's still technically being affected. Might be a different part of the texture. Okay, that's fine. Let's take a look at why, even though this is the same, why it doesn't offset it at the same time. Oh, maybe because it's still using it as a sign. Excuse me. There's no time. We're not trying to make it... there we go. That's what I want. Okay. Cool. Now, if I make this even larger, like 80, then we're going to see even more wave-like displacement. Okay. So I suppose we can make a uniform. Wind displacement 1.0. Okay. Uniform float. Okay. This is going to control the amount of displacement. Like that. Cool. Can Ozcan? I don't know. You ask Ozcan if he can Ozcan. How's it going? Okay, so this is looking good. Maybe what we can do here is make the leaves wiggle left and right a little bit as well. So we can do... I'm fine. I'm doing relatively okay, despite everything. Okay, so let's see. If we do this... So if we do this, it looks like it's working, but I want to offset it a little bit. So let's take this delayed, this variable, and then we're gonna add or subtract 0.2 from it. Okay, and then we're gonna use it for the x. There we go. So you see now it's a bit more. It's not offsetting on the x-axis at the same time it's doing on the y-axis. So it's got a bit more of a different effect. Also, one more thing that I think we should do. Right now it's just moving up. What if we take this value? Okay, we know that black is 0, white is 1. What if we subtract 0.5 from it? Which means it will offset it. There we go. It will offset it down, and then I think we can tone down the wind displacement on the x-axis. Okay, we need to do something about this whole texture here. Can we take a look? I'm pretty sure... it's the mask texture. Let's visualize that for a sec. Oh, that's a vector 2. RGB. There we go. Infinite youth. Good day. Okay. So, that does not look like it's black. But at the same time, we have alpha enabled. And I think if we disable alpha... Yep, there it is. There's the little bits of black. That is not good. Now, okay, there's an easy way to fix this. So, bring this back. We don't need the mask texture. We're actually just going to open up the fern in Blender again. And instead of displaying the image of the fern, we're going to display the image of the mask. Okay, child of ether, assets, models, foliage, fern. Have I used Pygame? Yep, I used Pygame for a text-based adventure, but it didn't last very long. I ended up switching to just using SDL directly, which is what Pygame is based on. Okay, cool. Here's what I'm gonna do. No, I don't want to merge. I want to go to the shader editor. And I'm gonna open the mask. And now we can see, as a matter of fact, here's what I'm gonna do. I'm gonna have duplicate, Shift D, duplicate this, and then gonna do additive. Yep. I'm just gonna add them both together so I can see them in an overlaid fashion. And it's just pure white. Multiply. Oh, they're both mask. Excuse me. There we go. Okay, maybe add. I can do mix RGB, but you know, this also gets the job done. All right, perfect. That's what I needed. Whoops. That's what I needed to do. And that's all we gotta do. Next time, I think when I'm painting the foliage, I can I can place little boundaries. so that our mask can be painted within those boundaries. You can also see there's a bit of a whoopsie gap happening right here. Okay. Hold on. Actually, why don't I make my life a little bit easier and do this? Oh. I don't know Python, so I'm gonna stick with Pygame. Yeah, do that because it comes with everything needed. Although if you do know Python, Godot can also work for you because it's running on GGScript, which is based on Python. So it's exceptionally simple to get to know. Okay. So this this thing here was meant to be used on vertices. Okay. So the question is which vertices is it messing with? Or which leaves? What is this leaf? It's got a big honkin' shadow on the left. There's this one. Okay. Got it. I think it would have been a lot better if I were to just adjust the UVs here, to be honest. We'll keep this in mind for next time. There we go. Cool. Okay. I need to dive on for the mute button anytime I need to sneeze, so I don't blow anyone's ears. Jeez. God forbid I ever miss. Okay. So, note to self. Next time I have to texture a leaf onto a plane, display both the multiply mask and the texture mask. Also, I think at this point it would have been better if I just selected everything. Nice. All right, that ought to do it. Let's export. Foliage. Okay. What not? Props foliage? The heck? Hello? Where did I save this? Furniture? Whoops. I guess I confused it before. Okay, and did I do no materials? Okay, we have it saved. Right. Wrong. What the heck? I thought I saved this. Foliage looks good. Thank you. That's photo soil. Materials, this was painted. And this is fern. Okay. Now. It's erroring right now, but that's okay. I do need to actually copy and set the resource again. Levels, start. Yeah, so you see, this is a local resource. If I set the fern, it updates it, but I can't populate the material. It's not going to stay. Okay, what do I not need? Mask. Okay. So this seems to be good. No vertices randomly moving away. Okay. One last thing I can do is I can offset it on the z-axis. But I feel like I need another delayed one by 0.4. So let's see. We're going to do noise texture. No, it's got to be the first one right here. Noise texture delayed. Delayed 2. Okay. It is not honoring the mask. That's because we're only multiplying this by the mask. We need to multiply this whole thing by the mask. Okay. Cool. So that works. I think we need to also be able to adjust the speed. So we do uniform float wind speed. Okay. We're gonna take I think it's this one. Time multiplied by wind speed. Semicolon. Save. There we go. Okay, so now we should be able to control the wind speed as well. Not great. Hmm. You know what? It doesn't really work because it kind of multiplies the entire time. So if I want to increase, everything just has to wiggle until it gets up to time. So if I do 2 or 10, we can't like we can't gradually transition it. Not unless we have our own time and we control that ourselves. Let's see. Is this a tool script? It is a tool script. We can do this. We could say wind export var wind speed. Let's do 10, and then var wind 0.0, and we need a regular process. Wind plus equals wind speed, the wind speed times delta. And then we're going to tell this thing to talk to the shader, and then instead of having wind speed, we're going to make it talk, we're going to make it actually just have a wind value like this, and instead of using time, there's no wind speed. Instead of using time, we're going to make it use this variable. And because it's a tool, we should be able to see it affected right away as soon as we go here. So we need to talk to mesh. Right, okay. Mesh, which is a part of its own multi-mesh instance. Dot mesh dot what? Surface one material. So I think we can do set, and then we pass this along. Surface one material, but we're not done yet. We want to go deeper to get to wind. Yeah. I think we can do this. Maybe. Like this. Let's see. Let's see if it works. No need for semicolon. That's not a requirement. It is not. But it could also not be doing it because we need to reopen it. Okay. Inval get index mesh. Oh. We need to talk to multi-mesh. Okay, so the shader is broken. Because the surface is gone. We need to make this unique, but thankfully, we had it saved. Fascinating. Is it getting cleared by this line of code? So we do this. Yeah, I think it is. Okay. We go to the mesh. We access. We can give the surface a name. Okay, let me double check this. So multi-mesh. We can supply the mesh. Within the mesh, surface get material. And then we tell it what is the material index we want to get. Okay. So surface get material. Would have let you just double click to select it, but okay. Okay, so we do mesh, surface, get material. There's only one material there. And then this should give us the material, and then set. Set what? What do we want to set about it? Wind. Okay. Okay, get surface. Oh, whoops. Get surface count does not expect parameters. Okay. Surface get material. There we go. All right. All right, come on. Hey, look at that. Nice. So now that we're sending our own wind into it, it's a little fast. Not gonna lie. Let's set this times 0.1 times delta. I don't want to make the wind speed 0.1 already. Okay. Nice. And then we can control it by adjusting the wind speed. Although I don't know why it's I don't know why it stutters when it has to update it. Insert that one sentence. Get well. Okay. Maybe we don't push it every single time. Maybe we push it... Well, actually, no, we do have to push it every single time. Because we need to advance the process. So we have wind displacement. Oh man, I don't think it should be stuttering this much. Oh, maybe it doesn't. Okay. If I set this to 0, there should be no displacement whatsoever. And then if we do this... Oh, we're not supposed to be touching that property at all. It's not for us to touch. If we do this, there we go. Okay, so if the wind speed is 0, it just stays still. Let's set the wind speed to 1. Point 1. Can we make it a float so that we can make it very subtle if we need be? Wind speed 0.0. Do you like Souls games? I played Dark Souls 1. I beat it. I tried playing Dark Souls 2. I have not yet... Whoops. Have not yet found the time to complete it. But I do find them enjoyable. Okay. I'm Dutch. We say Gesundheit. Cool. Okay. Let's set this to 10. And we need to make sure that this guy, the wind displacement, is actually properly affecting us. So this is where we use it. And wind displacement is supposed to be completely nullified. So we need to take it out of here There we go. Also, the subtraction of 0.5 is supposed to be done first, and then we divide it. But anyway, RPG, huh? Close to. I'm borrowing a lot of RPG mechanics. It's not gonna be like, it's not gonna be indeterministic in the terms of the narrative outcome. There is a particular story that I would like to tell, so it's not like a full-on RPG where you could just overwrite whatever ending that you deem necessary. At least not in the beginning. You know, when I get more experience, I'm sure I can put together something more Fallout New Vegas-y, like where you have more choices of rich endings. Okay. Not bad. So now we can control the fern offsets, and we have the control both of time. And speed. Fantastic. Okay. That's good. So let's return back to the shader. Let's get rid of, what do we don't need noise. Beautiful. All right. A book camouflage as a game. Yeah, pretty much. I mean, think of so many games that have a particular story that it tries to tell. You know, New Vegas, Outer Wilds, they all tell a particular story, and it has a definite start and definite end. Okay. There we go. Okay, it's loading materials. Okay, that's not good. I think, huh. Oh yeah. We got a little bit of white there. No proportional editing. There we go. Cool. Fern, no materials. That's good. And of course, we could technically use a material override here, if anything. In which case we don't have to worry about, you know, doing this whole cock and dance. Copy. Okay. Quick load. Fern. And then make unique. And then paste. Nice. I found myself having fun making a story. It is surprisingly fulfilling, which is why I write a story. Like, all of my games really start with a particular story. Okay, so now Instance count. Attempt to call a function set on null instance or null instance. Multimer scatter 45. Surface get material 0. Well, that's a lie. It's there, unless it isn't. Levels, yeah, it's stored locally. And there's a material there, unless we close it and open it. And then it's like, yo man, no materials here. And nope, it's still there. Evaluate get index tree types on base master node. Tree.gd 52. Interesting. This is totally unrelated. We have a master node, and then it's supposed to have tree types data in it, unless there's an error, in which case it wouldn't be able to get it. No, it's there. So it's probably because it's a tool script, and the ready function doesn't let it set up the data. Huh. Can use the same shader to create ripples in the water surface? Of course. That's actually what I'm doing over here. Let's see, where is it? Okay, so that's what I'm doing over here. And it's also what I'm doing out over here. Big ol' waves. Wi-Fi sucks currently. Sounds good, man. Okay, cool. So now that we have the ferns set up, we do still need to make them detect the player. So we need to figure that out. Where is it? There we go. Okay, so we'll take the ferns. Yep. 500 instance count 500. Interesting. Scatter. Clear. This doesn't look like 500 ferns, to be honest. Visible instance is 100. That's why we can't see it. Cool. Which sign is that? Yeah, that's quite literally what I did. Besides that, there's also a noise texture that's scaled up super high. Okay, now here we have a case where there's a fern in the character's way. We can adjust the seed until we get a pattern that looks a little bit better. That has him in the clearing, kind of like this. Technically, a better way would be to also have exclusion areas. Yeah, there we go. We can also just reposition the guy. All right, cool. So that's all fine and dandy, but now we need to do something. We need to be able to tell one particular fern to wiggle more than others. I'm going to set it to 100, and then for the sake of a test, we're going to set it to a 10 by 10 region so we can see every fern closely together. The whole reason why we're using code shaders is because code shader has access to something called instance ID, multi-mesh instance 3D. Let's see here. Let's take a look at the doc. Multi-mesh instance 3D. Gives us a multi-mesh, which has a bunch of functions. Set instance custom data. Can also do set instance color. Okay, so set instance custom data sets a custom data for a specific instance. Although color is used, it is just a container for 4 floating point numbers. Okay. For the custom data to be used, ensure that use custom data is true. Okay. Now, and then it has an instance custom information. Now, this takes a color value, which is just 4 8-bit integers. And those 4 8-bit integers will have to somehow be used to identify this particular fern. Now, let me double check something. So if we do 255 times 255, we get 65,000. 65,025 total values. So I could create a 255 by 255 texture, and that will allow us to make every single pixel. We only need to use 2 channels, but that will allow us to use every single pixel as a coordinate system. Okay, a coordinate system. And this is the maximum number we can set, like the maximum number of mesh instances we can set here anyways. 66. Or is it? Okay, maybe I'm wrong. It's a 16-bit integer. Did they like increase the total number allowed? That seems crazy. Okay. All right. So technically, this is how many total ferns we can have. But you can see that if I do set it to 65,000, then our performance. Well, the funny thing is this doesn't even look bad, performance-wise. This kind of, it's 30, 20 frames or whatever. But I'm impressed that it's able to handle this much. But of course, that's not going to be good because this is just a tiny little patch. If we set this to 30 by 30. Looking good on the ripples. Indeed. But yeah, this isn't something that we can really honestly use because we have an entire map that needs to be filled, right? And we need to make use of LOD systems. So we're gonna do this in patches, and realistically, the density of ferns is gonna be more like this, because we can't really even see. If we're in the beginning of the patch, we can't even see far enough to see the next patch. So this would be perfect distance for an LOD system. So we'll never go past 500, which means this is like way more than we will ever need. So what's the idea? Well, the idea is that we're going to take a 256 by 256 texture, Okay, and then we're going to use the two values of the 4 that we can set on the fern. We have this function here, set instance custom data. It allows us to set each and every single fern to have a custom piece of data, and it takes a color value just because it's a handy little way to package 4 bytes of data together, 4 8-bit integers. So we can use the first two 8-bit integers in the color, the red and green channels, in order to access a particular pixel on the X and on the Y axis. And then depending on the brightness of that pixel, that can determine how much that fern will wiggle when the player passes through it. Now, in order for us to set this up, whoops, wrong button, excuse me. Just wanted to mute myself. Okay. In order for us to set this up, we have this multi-mesh count, and we need to set custom instance data. So we're going to do multi-mesh set custom instance data. Now it needs an instance ID, so we're going to do 0, or actually instance ID, each instance, because we're looping through the number of instances. So this is going to be the number of the instance, 0, 1, 2, 3, 4. And then the data, well, we're going to make a color value, and it needs what? It needs basically it needs an X coordinate and a Y coordinate, which will be populated into the red and green. Blue and alpha will stay as 0, so I suppose let's make a variable, or actually no, we can just use this guy. But I want to make sure that it has an instance ID properly populated. So can we do something like modulate? So this is the instance ID. This is instance ID times 255 or 256. I think so. Modulus is this symbol. So that's going to go 0 to 256, and then once again 0. But how do we do the y-axis? I guess for the y-axis we can do each instance divided by 256 times, and then we floor it. Floor it. Okay, so this is just to verify. Okay. We go here. Okay, I didn't use print s. Also, for some reason, it runs this code, even though technically it shouldn't, and it fails here. Okay, this should not be happening really. Reposition multi-mesh. Is it because reposition multi-mesh? This is for repositioning all the elements. Vishal, good day. Old amount, old position. Already, old position is the global position. A global translation dot origin. That's probably the reason. Or no, global translation is the global position. Huh. Physics process. Okay, well, let's see here. Oh, right. I think we need to make sure not every one of them is printing this. So let's do export var test false. And then we're going to print this only if test is true. Okay. Fern is the only one that needs to have it. And then generate. Ah, interesting. This is for repositioning it. So we need to move it. Randomize multi-mesh. That's what we need. Okay. Save it up. Okay, so let's see what we have here. So it goes 0, 1, 2, 3. This is going to go up to 255. And then 255, and then goes back to 0. And this goes to 1. And then we get back to... Well, we don't get back to 255 because we only have 500 ferns here. Cool. So that technically should do it. So how is this going to help us? Well, we're going to go here. We're going to talk to the multi-mesh and then set the color. This color is going to be set by this, and this color is going to be set by this. Okay. And I think there's also one more color, which is, or two more colors, which is this and this. Is that going to be accurate though? Can color take values to 255? Come on. R8, G8, B8, A8. It has properties. We can set the RGBA using 8-bit integers. Huh. Let's see. Oh, color 8 is how we do it. Okay, got it. So we gotta do... We can't use just regular color. We gotta do color 8 in order for it to work with 8-bit integers. Now, color 8 is not existent, so I guess it's color dot color 8. No? Okay, let's double check that. We need to close everything. Close all other tabs. Come on. I'm clicking. There we go. Okay, so color 8. Is that a different class? GDScript color 8. So I guess it's just a standalone function and it gives us a color value. So, this? Yeah. Okay, so this is the first value. Expected 3 arguments. Okay, sure. Do we give it 3 arguments? Okay, there we go. Cool. And what's it complaining about here? Parentheses. Nice. Okay, so that works. Now every single texture, every single fern should hypothetically have a red, green, and blue value. Now, we will have access to that data using instance custom. Okay, so for the sake of a test, I'm going to do this. I'm going to take this whole grid and then paint it with black. And I'm going to take a pixel brush, because we are working with individual pixels here, Every single pixel represents a fern. So we do this, take a pixel brush, and then place a white color there. And then we'll just export this. Okay, so this is fern index texture test. Okay, so we go foliage, engine, utility. Yes. Cool. Alrighty. Let's go back in here. I swear to God if this works. Go back here. Go back to the shader. So we need to have a way of supplying this texture. Whoops. Not what I wanted to do. Okay, so this is going to be... So this is index texture. Let's call it that. Index texture. So we back up. Index texture. Fern. Index texture test. Nice. So it's a texture all black with one single pixel being white. Okay. So we'll go to the shader. And then I suppose if we were to create a wiggle, like the player walking through it, we can just multiply one of these values. We could do it as a separate operation. Vector 3. We're going to keep it simple. Sine, time, and then 0, 0. Beautiful. Okay, now this is just a test. It is meant to make it painfully obvious when something is moving. Oh god, they look like cockroaches. Okay. So, let's make a float my index value, and in this case the characters have no volume. Yeah, that's right. So we take what? We take the texture, index texture. We need to, I believe, parse it through the texture function, and then instead of UVs, I believe we need to give it instance custom. Let me double check this. Duplicate. Shader. Oh, come on now. Go for shader, shader. Okay. And then not quite. Playing videos. Shader material. Okay. Where's the page? Oh, right. We have the spatial shaders already open here. Instance custom is a vector 4. Okay. Vector 4 of what, though? for particles, instance custom data for particles mostly, instance ID for instancing. Instance ID for instancing. Hold on a second. Can we not use this? It's an integer. Okay, before we do this, let's go here. So we're going to do red, green. That's the first two pieces of data. And it needs this needs to be a vector 2 because UVs used to be supplied here, and UVs are vector 2. Well, I guess, invalid member of int. Oh, wait, I'm not supposed to be using instance ID. I'm supposed to be using instance custom. Hold on. I'm really tempted to try that, but let's just see about red and green. Assignment of vector 4. Right. I think we just take the red value. And we will multiply that by the sign. We took the index texture, instance custom red, instance custom green. Maybe it's the opposite. No, I mean, technically, even now, only one of these is supposed to be moving. I think it's because UVs work in values from 0 to 1, but we're sending an 8-bit value from 0 to 255. So do we have to divide by like this? Not really. Instance custom. Is clamp? Yeah, clamp is here. Here's what I'm going to try. If each and every one of these it has an instance index, which we have seen here, right somewhere. I think it was here. I'm going to try something. Instance custom. I'm going to use it as an index to pull up a particular spot on the texture. I don't know if it's going to work. Or maybe not even. I mean, technically this should have worked. And there's no such thing as like, what? You int 8t? Yeah, there's no integers here. Unless we could do integers like this. Okay, we're taking the index texture. It is right here. There's one single pixel up there. Yes. It is uncompressed. hypothetically, if we were to visualize instance custom red and green, we should see it. So if we go here, we say albedo equals vector 3, red, green, just like that. And then blue is going to be 0.0. We should see different colors. Unknown identifier instance custom. Well, wait, so we don't have access to it in the fragment shader. What? Instance custom. Instance custom variable contains the instance custom data, which is particles. This information is usually X, rotation angle, Y, phase during lifetime, animation frame. All right, but that's only if we're using it in particles. We're not using it in particles. Interesting. Okay. 0 to 1. So it's a float. Can we do this? Do we have instance access to instance what? Iron, good day. Welcome back. Okay, let's see. So we're looking at instance custom, but there's also could store it in the variable maybe. Yeah, but I'm trying to debug it to see what's actually in the variable. Where is it? Need to access in the fragment shader. Oh, you're talking about that. That is actually a smart idea. We can just do, what is it? Integer ID equals 0. And then const. It's not a const though. Well, hold on. It's varying, right? Varying ID, integer ID equals 0. Does not like it. Float. Only float vector 2 or array of this type is allowed. So can't have a varying, I guess, uniform. Can't have a varying integer. Yo, man. Okay. ID equals instance custom. Assigning to uniform. Oh, right. So instance custom is a vector 2. That's a vector 4. That's right. I'm thinking instance ID, the other one. Vector 4. Okay. Cool. And then we pass it along here, and then instance custom should be available to us here. Unknown identifier instance custom, which is ID now. Okay. So this is what we're looking at, which means instance custom has not been set unless we just have to kind of run the generate function again. Huh. So that would explain why it's all the same. Let's double check the code. Okay. multi-mesh, set instance custom data, each instance. Take the color 8. Oh, custom data format has to be set. That is something I forgot. Let's see. Custom data format. Now, if we set it as a byte, does it show up as a byte in the shader, or does it still show up as a float? Okay. If this actually works. No? Okay. Seed value? No. Okay. Oh, it cleared it. Because I can't set it now, of course. So I gotta set this to 0. Set this to, I guess, byte. Yes! Yes! Okay. Now, it's only the red value. Okay. Okay, what if we set this to a float? Yeah, okay. Byte it is. All right, okay, making progress. So that's good. Let's get back here. In the output, I'm just going to double check if the IDs have been set. Custom data format is multi-mesh custom data none set is true. You liar. Okay. I'm going to set wind speed to 0. So none of them are moving. And I'm going to make this shader move along, I guess, up and down. Sine time times my value index. Right. So that's fine. Actually, just as a test, these are the various IDs that we have now applied, although it seems a little strange. Red, green, blue. Use floats for highest precision, apparently. Fair enough. So if we want to use floats, float here, 500. And then we go back to the code. Instead of using color 8, we just do color and when it calculates this, we divide it by 255 because that's the maximum we can get to. And then this also divided by 255, which I don't need brackets here. Nope. Color. That doesn't make sense. That's the one value. That's the second value. That is the third value. So this, oh, that used to be it. Right. Cool. Okay, so now we're sending floats into it. Well, they're kind of green. They're greenish. They should be, for the most part, red. Excuse me. They should be red for the most part. Yeah, so the red index gets up to this much. Probably because we need to divide it by a float. Because it's a stupid. It'll be stupid. There we go. Hey, okay. And then do we have a little bit of green? I saw a little bit of green. So I reckon the little bit of green is there. Nice. Cool. So now that we've done this, it's a float. Oh, geez, that's a lot of prints. So we go here. No, we don't go here. We go to the shader, and then we try this whole thing with the vertex offset. Okay, so we take index value. Oh, yeah, we actually needed that for testing. We take my index value. Only if you have 256 by 256 instances. That amounts to 65,000 instances, which is like nobody, as far as I know, ever uses that many instances at all, right? So that's like in access. That's more than enough. Okay. Now, instance custom. We take red, and then I think we're reusing this. Okay, so they're all moving right now, which is not what we need. We take the texture. The texture has a single pixel set to white. So we take that texture. Yep, has been supplied. And then instead of the UVs, we're using the red. Oh, which is already a float. Can we do this? Oh. Well, I mean, technically, only a few of them are wiggling, but that's still too much. Only one of them is supposed to be wiggling. I'm just gonna set this on the y-axis so it's much clearer. My index value. Float. Okay. Cool. I'm just gonna make it ABS, which means it's probably gonna have to be negative. No? Okay. So that works. It doesn't work perfectly, but it works. Maybe we have to flip them? Which honestly wouldn't really explain it. No. Maybe my division could be a precision issues. Yeah, it could be. It would be nice if we could just deal with integers. I mean, using floats for quote-unquote precision is not really necessary when I only have, you know, 500 elements. Maybe, hold on. Maybe my texture is anti-aliased. Because then it would be blurred, right? Hold on. What is this? Fern. Texture test. No filtering. No mipmaps. Yes! No! Damn it! Okay. Well, it was at least sort of in the right direction. I think we need uncompressed. Ah. So it's less, but it's not quite. There's no normals here. What else can I do? sRGB. No repeat. That's what it was. That's what it was. So it was a repeat property on the texture. Holy crap. Okay, hold on. So this means that if I were to also mark this one and then save it. Oh, whoops. Yes. Yes. It is working. Oh. Hell to the yeah, dude. Okay, so that's working, which means um all we have to do now is give them a more interesting wiggle, and we are going to create an area node with a whole bunch of shapes scattered around, and these shapes are just going to sit there and wait for the player to touch them. A signal will execute, and then we'll populate a white color on that particular pixel based on the index of the shape that we created. Okay, cool. I'm gonna pause here for a minute, stop the recording, take a 15-minute break. We'll come back and we'll program that in. God damn, dude, that's awesome. This is gonna be super useful for foliage and Automicon. It's gonna be super useful for just any game. Maybe even like in Dreadtail we can do something interesting. Damn, this is awesome. This is flipping awesome. Okay, cool. Be right back. Hello everybody, welcome back. I forgot to stop the recording when I left for the break, so now there's gonna be like this 20-minute pause of nothing happening in the video. Cool. Alright, so now that we've gotten ourselves the ability to mark any one of these textures, any one of these elements with an index, which I think is super freaking cool. If it works. I think it's because there's no ferns on the second row, which makes it for quite a huge texture actually. Let's see. We only have like 500 elements, so if we do let's say the maximum number of instances at any point in time is going to be 1000. So 1024. If we divide it by 2, that's 512. We don't need to divide it by 2. We need 1024. We need to figure out the square root of this. 32. Now, is that right? 32 times 32? Yeah, nice. 1024. Cool. So we can actually just make like a nice teeny tiny little 32 by 32 pixel texture. Like this. Okay, and we'll say this one, and this one. That's good. And then we're just going to go back here for a second. We need to change this. So we do divided by 32, or modulus 32, divide, well, 33 technically. Yes. Actually, no, 32. And then 32. Yes. And then, technically, that's it. There we go. So that gives us, even the indices are working now. So that gives us our 3. And then if I do one more, like this, I don't need to save it. I do need to export it. Now we got 4. All right. So, here's what we're going to do. We're going to give these a nice wiggle effect. Because right now it's not really doing that. Let's see. Let's take what? What are we going to do for the wiggle? I guess we can do X and Z. And we can do that by doing sine. Let's just tone it down. Times my index value, yeah. So sine and then cosine. Okay. Now we're also going to add the coordinate time plus vertex.z. Okay, now this needs to be very small. So multiply 0. Actually, we're going to multiply it by the mask texture. So multiply mask.red. There we go. So only the extremities are being modified. And then this needs to really tone down. Okay. This needs to increase the speed, like 5. And I think it also needs to increase in rate. You know, maybe I can just reuse the noise texture instead. The sign looks way too simple. So this is player collide wiggle. Okay, so noise texture wiggle. And then instead of the sign, we're going to be applying this. Instead of a cosine, we're going to be applying this. Just the red channel, because it is a texture. It's got red, green, blue channel data. Okay. There is no wind. And there's none of this stuff. Texture noise. Oh, right. Plus time. Okay. Times 0.5. Okay, so that's how much it wiggles. But we don't want to wiggle in the same direction. So let's subtract 0.5. That's right. Mask. Oh, not mask texture, excuse me. We're not supposed to modify the mask texture. We're supposed to modify this. And then subtract 0.5 so that the gray color is considered 0, black is negative 0.5, and white is positive 0.5. Okay. Okay. There we go. Okay. Can we wiggle offset? And then we're going to do plus. Let's do time times 0.86 on this one. And then this is going to be done on the z axis, so that it looks more like this. Now we don't want it to be super fast. Okay. So we take this, maybe multiply by 2. Actually, we can just get rid of the multiply by 0.5 to tone that down. Mask texture. I guess it's this guy. Okay. Technically, these two are the same now, so let's add plus 5, which that doesn't make sense, because if I add plus 5, it just adds the same exact position 5 times. It's got to be a much smaller value. Interesting. What if we multiply? It will not be good. Okay. I think we need to make this smaller. That's the texture size. Okay. Let's go even less. Interesting. I think we can comment this out so we can see the texture now. It's not the best, but it could technically do something. Let's do float, constant float, S, set it to 20 or 30, and then we're just gonna use S here, and it's got to be 30.0. So I only have one place where I need to adjust it. Okay. Now, what if I multiply the mask by itself? So take the mask, multiply it twice. Okay, so that makes the center be a bit more stable, which kind of makes me think I should also do this for the wind effect. Let's see here. Wind speed set to 10. Maybe not. I think that's good for the wind. The wind is a bit stronger. This is the player walking through it. Okay. Cool. So, now that we've done this, here's the deal. We don't want the texture. We don't want the texture to be populated manually. We want the texture to be unique. So, we need to generate a texture. We need to make sure that it's only done in the editor hint. Okay. As a matter of fact, maybe I'll do it here when we randomize the mesh. Okay. So we'll talk to the multi-mesh. Get surface. Get surface material. Yep. Surface material get. Man. Mesh instances have get surface material. Multi-mesh instances have get material or surface get material. What the shit? Okay. You can tell different people were responsible for different these different features. Okay, anyways. So we need to generate a texture. So var texture equals, I think it's just texture.new. Let's look it up. Okay. It's a resource. Texture is a base. for other resources cannot be used directly. Okay, so it is used by, what is it? Texture 2D? Mesh texture, external texture, noise, image texture. Okay. So this is how we create a new one. Texture, image.new. We don't really want to load anything into it. We can create from image. Okay, so create width, height, format, flags. And then here we can set the data from image. Okay, got it. So there's two resources involved in creating a texture. So first, we do image texture dot create. Width is 32, height is 32, format RGBA. RGB8, because we don't need alpha. Flags, I guess we'll just leave that as, actually no. We do want flags to be set up. Okay. Oops. Flags. Flags. The texture's flags. What do we got here? Repeat, filter, use magnifying filter to enable smooth zooming in the texture. Nope. Mirrored repeat. I think we need to AND these components together using bitwise operators. So flag repeat, we want to be false, which I believe we then just don't use it. So hold on a second. Let's say we disable everything. So in that case, it's just 0, right? We don't need everything here. Okay. So that creates a texture. What do we need next? We need image. Let's take a look at the image. So we created a new image resource. Well, hello. We can fill rect, fix alpha, flip. Man, you can do a lot of image manipulation here. That is actually perfect. Oh man, with this stuff we can actually do quite a lot of interesting features. Cool. Okay. Shrink to 2 times sRGB to linear. We can set pixel XY coordinates in the color. That's cool. Can we multiply it by itself? Blend rect. Set the pixel of an instance that is close to the player every frame. Well, I want it to dissipate over time. So that's kind of what I'm thinking. But I don't think we need to update all pixels at all times. I could detect using an area node when the player walks over, convert the index of the shape of the area to the X and Y coordinate, and then log it into an array or dictionary, and then loop through the dictionary in order to only set that one pixel. because we don't really need to update each and every single one of these pixels in every single cycle. But if I can blend the image together, then we don't even need to do that, because I just set the pixel, and then over time it just blends the image back to black. So that's why I'm kind of looking at blend. Alpha blends source rect from source image to this image at the coordinate destination, clipped accordingly to both image bounds. Must have the same format. Not positive size is treated empty. Okay. There was a fill. Fills the image with a color. But I don't want to fill... fill's just going to override all the colors. Blend low alpha pixels with nearby pixels. Don't want that. Get data, get format. So I suppose I'm going to have to log the X and Y coordinates of the pixels that have been set. Okay, fair enough. So I'm going to do this. I'm going to take the image, fill with a color of black. And then the texture is going to be set. I think we need to do image, create from image. Well, hold on a second. Creates an image texture with width and height, format, and flags are supplied. Initializes the texture by allocating and selecting the data from an image with flags from texture flag. sRGB is linear. Well, okay, so what's the difference though? Does it not create its own image already? If I just do create. Set data. Oh. Set data. Replaces the texture's data with the new image. I don't want that. But this means that it creates its own image though. We have storage. What's storage? The storage type. Nope. Creates a new image texture with width and height. It doesn't return anything when it creates it, so how do we access it? There's set data. Texture has to be initialized first with create from image method before it can be updated. The image dimensions format maps must match existing texture. Otherwise, it has to be recreated with create from image. Use this method over create from image if you need to update the texture frequently, which is faster than allocating additional memory to the new texture each time. Right, well that makes sense. So I guess set data is what we want. So it sounds like it it honestly sounds like it's copying the image contents. Okay, let's do this. I'm gonna make this variable be, whoops, up here, because we need to be able to talk to it. image contents. Okay. We're doing image contents fill with black. And then I suppose we need to set the texture. What property are we setting? We are setting index texture. And then we're setting it with this. Okay. Create only call from an instance. Right. Image texture dot new, which we create a new image texture. I feel like something might be missing from the documentation. So let's say we do this. Okay. New texture, contents, create the contents, fill it with black, set the data, and then populate the texture into the shader. Nothing is wiggling. Now, even if I do this, which we have errors, so we might as well pay attention to that. I also should get rid of the index printing. We know that works. It's just clogging up my output right now. Can't even open it. Godot's busy opening my nonsense. Okay. Go away. How did you learn GGScript? Just dove into it and started using it. First it was using the documentation, example scripts in the documentation. Okay, what do we got here? Texture active is true, returned ref image. Rasterizer. Okay, so it's complaining about it. Oh. Image must be locked with lock before using set pixel. I'm not using set pixel. Unless it's just like an internal function call. Let's see here. Lock. Locks the data for reading and writing access. Sends an error to the console if the image is not locked when reading or writing a pixel. Interesting. Sends an error to the console if the image is not locked. So I guess we gotta lock it. That's a little strange. Okay. Image contents. Yes. Dot lock. Cool. Taking forever to save. Still complains about it. Although data size is 0, so I suppose this is the issue. So texture dot create 32 by 32 format RGB 8 and then flags 0. Okay. You know what? I think it's because every single one of these is every single texture that we place into the level is attempting to do this. Let's give it an export variable that only player reacting ones will actually interact with it. So let's do export var reactive false. and then save it. Did you watch any tutorials from YouTube to learn GDScript? Only if I was completely clueless about what's happening. If I'm looking at something and I don't understand how to get it to work, then I'll search something up. Okay, so if reactive were you able to write code and make games after you learned? Well, it's not like I learned and then that's it. I'm just continuously using the documentation to help me write games. It's not something that you really memorize. There's a lot to memorize. Okay. So only if reactive is true, we are going to attempt to do this. So there we go. Okay. Now it says data size 0. Image must be locked with lock before using set pixel, I suppose, because we're trying to fill it. There we go. Rasterizer storage. Let's not complaining about this anymore. Okay. So now, if I were to talk to the texture, and let's do set pixel 0, 0. I set it to color white. Then we should see one of the ferns jumping around. I am not sure why it's taking so long to save. Okay. Do we see it? It might be subtle. Or it might not be doing anything at all. Let's do 1, 1. Learning from documentation enough? I mean, at this point, you might as well go see for yourself. When you're starting early on, you might be kind of obsessed with the idea, what's the most optimized way of learning? The path that is going to save you the most amount of time, get you to learn the most amount in the shortest amount of time. All that stuff is nonsense. You just gotta get started. Okay, I'm not seeing anything moving around. But at the same time, it says it's a 32 by 32. Everything here is disabled. But it's not a resource that's on the folder. So what happens if I set this to 16 by 16? Is that gonna do it? Image new. Huh, hold on. Pull byte array. That's how we can talk to the data directly. That's interesting. Blend rect mask. Okay, so if I set this to 16 by 16, we should see 16 by 16 here. I believe so. Yep, Nice. Okay, so it's updating. That's good. Okay. Now, we should be able to see one single pixel in the top left corner. It has to be white. Now, I don't see it being white. Also, it seems like if I'm trying to resize this, it's taking a mighty awfully long time, which kind of suggests that maybe this is creating a texture continuously, which is of course not good. Let's print texture created. Let's do index texture created. Hmm. Can I clear this? Hmm. Do you mean documentation from the app or documentation from the website? Both. They're both very handy. Although the documentation from the website is the one that has example scripts. So if I need to figure out, oh, how do I talk to a sprite? Oh, look at that. We got properties. I can set the frame number. I can set the texture that it's displaying. Set if it's centered or not. Get the rect dimensions, yada, yada, yada. And then, oh, I want to animate. Okay, well, cool. Let's, animation player. Hey, look at that. You have a function here to play an animation. And then check if it is playing an animation if you need that. So, stuff like that. But there's no code examples here. Eventually, you're not going to need code examples because you could just look at the function and be like, oh, well, that's pretty clear. You know, just a matter of experience. Cool. Okay, now, interestingly enough, it doesn't populate the actual image data here. So maybe texture set data replaces the texture's data with a new image. The texture has to be initialized first with create from image. Oh, before it can be updated. Got it. Okay. Got it. So we have to do create from image and then give it the image, which means the image has to be created first. Create a texture, and then we don't, technically for now, we don't need to set data, but hopefully in a little bit we'll take a look at that. Okay. So we should be able to see an image here. Hopefully. Well. Oh, hold on. We need to make sure that the flags are the same. Texture, image lock, fill, set pixel. That should do it. Well. Create from image. New texture. Texture.create from image, image. Sprite texture equals texture. Okay. We didn't have to lock the image here. Create from image. Professional developer. Oh boy. I think that title is a little a little fancy for me. Appreciate nonetheless. Image contents, create a new image. Lock it. We should be able to see it here. Because we saw it before. Although, no, we didn't. Can't really create a new image this way. Maybe it's because the formats don't match. Okay. Is anything here returning an image? Get rect. RGB to sRGB. Okay. Does anything here accept flags? No flags. So what gives? Okay, we make a new texture. Create from image. So maybe this image just doesn't complete. Like there's something missing. Create. Width, height. Okay. So we do create 32 by 32, false, no flags. So we have a texture of this dimension. I think that might be the missing link. So we have an object, but we don't have the texture container, the data for it. Well, let's see if it actually. Hey, look at that. That is, well, that's there. That's there, all right. Now, do we see any movement? If I set this here, I should see some movement. There you go. Okay. But that's because the very first fern is wiggling. That one right there is wiggling too. Okay, so if I set the very first pixel, which is 0, 0 to white color, we should be able to see it. Okay. If I can figure it out in the next 30 minutes, that would be ideal. Oh, I see a pixel there. I do see a pixel there. Do I see a pixel there? Hold on a sec. I don't understand why it takes so long to update this whole thing. Okay, sRGB. You know, it would help if I set the dimensions to be 10 by 10. And I didn't have to look at too many of these things. Let's go like 100. Okay, so just as a test, if we populate this, First fern. There we go. I think that's the first one. Let's see. Export. Override. Oh, that's the first one. Okay. Cool beans. So this is the one we need to pay attention to. So if I do scatter, it is going to regenerate a new texture. Here it is. I don't see the pixel be populated there, so so it didn't. What if I do red? Is that gonna work? Not. Because I need the constant, the proper constant. Hey, okay. Right, so if the whole texture is filled with red, it is going to work. Now, set pixel, what if we do 1 and 1? Maybe that's the thing. Like, there's no pixel called 0, 0, or pixel number 0, 0. That could actually be the case. Let me double check the documentation for this. I don't see anything moving, but let's see here. So image, set pixel. Okay, sets the color of a pixel at x or y coordinate if the image is locked. New image, set the size, lock. Oh, does not have an effect. So I guess we need to unlock it afterwards. Is that what we gotta do? Hmm. No. It doesn't seem like we need to unlock it. Returns the color of the pixel at x and y coordinate if the image is locked. If the image is unlocked, it always returns the color with the value 0001. It's the same as getPixelV, 2 integers arguments instead of vector 2. Okay. Locks the data by reading and for reading and writing access. Sends an error if it's not locked when reading or writing a pixel. Okay. I suppose it has to remain locked. Actually, we fill it, which works, and then we set pixel, which seems to not. And then we push it into the texture. So we should be able to see a tiny little pixel over there. And yet we don't. Huh. Image texture new. Let's try placing a pixel like smack in the middle of the whole image. We should see a dot right here. And yet we do not. Let me try this. 1, 1, 1. That's it. I see the fact that it's taking this long is a little sketchy, to be honest. Now, I wonder, do we have to place this into the texture, or can we just set image contents directly? I doubt we can. I also don't like how long it takes to save. Oh, yeah. No, that's not going to work. So the image data has got to be wrapped into a container. Right. Okay. Let's double check something. Dot image set pixel doesn't work. Why is set pixel not working for me? You need to call update. What are you talking about? Update. Unlock. No update here. Is it here? Set data. Replace the texture data with a new image. That's 5-year-old. 5-year-old answer. Create an image RGB8, not RGBA8. Not sure if that affects anything. Q redraw. No, that's for redrawing the whole node. Create from image. Okay, so it tells it to create from image after we do all this, which we do here. Does create from image return anything? Nope. Void. Image contents. Okay. Okay, this is a little sketchy. It says randomize. It ran randomize 5 times. I think it does it anytime any sort of like saving a moving operation takes place, which isn't good. I might have to double check when randomize gets executed. I think it might be the positional code. Actually, we can find that out if we use a stack trace. If I put a breakpoint right now, if it ever recovers, you know, I feel like maybe we'll have like a memory leak issue. Uh, 2.9 gigabytes. Okay, we're gonna keep that open for a sec. 2.917. Maybe it just keeps creating new textures. I think that's exactly what's happening. And I might want to close this. Okay, let's try that again. All right. Well, so far the project is 800 megabytes in memory. So yeah, I think it just kept creating textures over and over and over again. Okay, let's see. So I click scatter. We're at 952 megabytes. One, yes. Okay, there is a texture here. 972.5. And then if I do this, still not 72.5. Okay, so let's get back here. So if every time I save, 969, 970.05, 970.06, 971.06. Oh, it went down. Okay. Let me double check this for a sec. So image must be locked before using set pixel. I did. It's right here. Yes. And it's only if reactive is set to true. And then here, reactive is by default false. So this is false, this is false, this is false, and this is the only one that is true. Okay. I'm going to put a breakpoint here, because every time I save, we can't have a breakpoint because this is not running. Can't have a breakpoint on tools. All right, you know what? Maybe we don't have it be updated whenever we move it. Although, for now, for the sake of testing, we're going to leave it. Okay. It's still complaining. Image must be locked with lock before using set pixel. So do I have to, like, lock it here? Okay, well now it's spiked up to 1 GB and 2. I still don't see the pixel. And it's still complaining about the locking thing. Okay. New image, create. Image format RGBA 8. Maybe that's the issue. Maybe it's got to be RGB alpha 8, which kind of makes it, I think that's actually kind of logical. There we go. Flags can stay as 0. I think that is logical because shaders take texture with alpha in it. So it has to have alpha, otherwise it won't be compatible. So me creating an RGB8 texture might have been dooming it to not be usable. Although it's still not usable. Image must be locked with lock before using set pixel. What are you talking about? Oh, right. First we create, then we lock. Is that a pixel? No, that's a smudge on my screen. Damn it. Okay. See, if I do this, everything is wiggling. If I do black, but then set pixel, maybe set pixel works in a very peculiar way. Sets the color of the pixel. If the image is locked, gives me an example, but doesn't show me what kind of color it's using. Okay. Maybe it's because the alpha channel is missing from the color. So it's just painting a transparent white pixel every time. I swear to God. Oh, lordy. No, I don't see the texture still. Hold on. I don't see that pixel. Image contents. Well, we're basically up to 2 gigawatts of space on the hard drive now, or on the in the memory. So every time I save, something keeps growing. I suppose today is the kind of day where we just have to figure something out. Does it have to be sRGB or something? Maybe. Let's try setting the, what is it, flag. Storage, no. What's the constant for this? None? Okay, I gotta take a look at the image texture flags. Enumerators. Compressed, lossy, raw. No, it's not quite what I need. Flags, texture flags. Format and flags. Okay, so when we do texture new, create from image, and it wants the flags. Okay, so we go texture flags, flag, PD surface, repeat, filter, bitmaps, flags default. Default flags have bitmaps, repeat, and filter enabled. What about this one? The sRGB one. Oh, convert to linear. Convert texture to sRGB color space. Alright, so we go here. Now, we found this under texture, technically. But it's curious that it stopped complaining. It might have complained because it didn't exist. Oh, that's because image texture inherits from texture. So whatever flags texture has, image texture has as well. Okay. I don't know why I'm running it. I shouldn't be running it. Okay. Let me try something. If I do fill rect or fill black, and then I do fill red, is it going to be red? It is going to be red. So does that mean that set pixel doesn't work? What if I set pixel to color black? Is that going to set a black pixel somewhere around the top left corner? It will not. So set pixel seems to just not work. Okay, let's take a look at this. Godot set pixel doesn't work. Fill works, but set pixel does not. Okay, we need specifically set pixel. They're unlocking it here. Of course, they're asking the question. They didn't have to like it does the fill. I don't have to unlock it to get the fill to work. Now watch it actually work. Nope. Doesn't. Okay. I'm gonna ask the a question on the Godot subreddit. Hopefully somebody answers. If not, then oh well. But I got about 5 minutes left anyway, so I might as well end it now and return later on. I got a meeting with a voice or a sound engineer. Cool.